All right, this is our next lesson for Math at Work 10, looking at girth and midpoint calculations dealing with working with length. Okay, so this is the video you would watch to complete the assignment that's on Google Classroom that's entitled Working with Length. Okay, so here we go. Okay, so what we're going to be looking at now with our objects is two other aspects. One, calculating the girth of an object, and two, calculating the midpoint of a length. Okay, so girth would be something that we would have in a three-dimensional object, whereas midpoint would be something that was in a two-dimensional length. Okay, so previously we have looked at calculating perimeter and circumference of, again, two-dimensional objects, okay, going around a 2D object. And we'll also need to use some of those skills in this lesson as well, right? We're talking about going around an object, but now applying it to going around a three-dimensional object, okay? Because when we talk about girth, it's defined as the maximum distance around a 3D object perpendicular to the length, okay? So the length is actually not going to be used in that. So just to kind of show you what I mean here, I'll flip to the whiteboard so you can see what we're talking about. Okay, so when we talk about that idea of girth, right, so if we just think about a relatively simple rectangular prism here, okay, first of all, length is defined as the longest side, right? So if we were actually going to say, okay, well, it actually matters what's height, width, and length, length is going to be whatever the longest side is. So if we were to measure this object, and from this diagram, it does definitely appear to be that this length, right, this value here would be the length, okay? This would be the height because it's going up and down, and this would be the width, okay? So this is the length of our object, and the girth is perpendicular, which means it creates a 90-degree angle to the length. So what that means is that if this is the length, right, going flat this way, perpendicular to that is going to be going straight up, okay? So it's like if this is going straight, perpendicular would create a 90-degree angle going like that, okay? So the girth is going to be not including the length, but going along the length and going up and over and down and over again, okay? And that distance going around is what we call the girth of an object, okay? So that's what we mean when we say girth, right? And again, it's already kind of in here in the notes that length is defined as the longest side of that 3D object, okay? So you had a diagram here in the notes as well that just kind of explains again what I just drew there on the board for you, right? So in a rectangular prism example here, right, again, the length was clearly the longest side here. There's that 90-degree angle, right, perpendicular, meaning creates a 90-degree angle with. And then that red line that you're seeing there is the girth, right? So going around the outside there, right? So the length is that longest side there, and the girth would be essentially the perimeter of this square if you were just looking at it front on, okay? Same idea here with a cylinder, right? So like the length would be the longest side, and in a cylinder, again, it's like your length is really the only option you have. So you'd have the length going here, and then the girth would be going around. So it'd be equivalent to the circumference of the circle if we did it that way. Okay? So why would we need this type of measurement, right? We've often talked about, yeah, we make sense why we need perimeter, why we need area, where do we need a situation that involves this extra measurement. So a big spot that it's used is actually using in pricing packages for shipping as one of the dimensions, right? So they're actually measuring, length, weight, and also potentially they're measuring how much it is going around. Okay, so those would be something. So one particular situation that we're going to focus on is a formula called L plus G, or length plus girth, right? So if you took the length of the object and then you added the girth around it, that might be a value that they actually use to price packaging for shipping. All right, so let's take a look at our sample problems, okay? So in this case, Erica has two rectangular packages. She knows the length, width, and height measurements of the packages, and package 1 measures 2.5 meters by 1.5 meters by 1 meter, okay? And we're being asked for what is the length plus girth measurement. Okay, yes, you see the solution there on the slide. I'm still going to go to the whiteboard and show you how we would actually do this as well. Okay, so again, we know that this is a rectangular prism shape, okay, and the values that we have are 2.5 by 1.5 by 1. So again, if we draw this as kind of like a rectangular prism this way, right? We know that the length has to be the longest side, which in this case is the 2.5. So there would be our 2.5 meters. We're not sure whether the 1.5 and the 1 are the width of the height, but we can just kind of associate them. So let's call it that's 1.5 meters there, and let's call that 1 meter there. Okay, so already, if we're being asked to find the length plus the girth here, the length we know is supposed to be the longest side, which is very obvious straight from the question. That's the biggest of the three numbers, so it's 2.5 meters. Okay, and then the girth would be that measurement going around that's perpendicular to that, so it's going to be this, right, which is that height of 1, right, plus this length here, which is going to be the 1.5. And then this would kind of come down again this way, right? That's another 1. And then across the bottom, which is again another 1.5. Okay, so we add all that up. So your 1.5 and your 1.5 is going to be 3, 4, 5. So that's your girth measurement. Okay, so ultimately the question was asking what is the length plus girth, or the L plus G measurement? So the length was 2.5 meters. And the girth is 5 meters, so if we add those together, our length plus girth measurement ends up being 7.5 meters total. Okay? All right, and again, you see that same answer that's there typed in the solutions. Okay, our second rectangular package. All right, so we've got another one that we're dealing with. This one measures 3 feet by 3 feet by 10 inches. Okay, so we're going back to an imperial unit there. Okay, so we've got 3 feet by 3 feet by 10 inches. And again, we would like the length plus girth measurement on this. So big thing to keep in mind here is the fact that these are in different units, right? Feet, and inches. We can't just go combining things if they're not in the same units. So one, we look at the question, and I believe the question actually asked us what is the value in inches. So we need to start by actually using our lesson that we've done before on conversions to do those conversions. So if you remember 3 feet, we have 12 inches in a foot, so we can convert this by taking what we have, right, starting with what we have, multiplying by our conversion factor. What we want goes on the top, what we have goes on the bottom. There are 12 inches in 1 foot, multiply, we cancel, and that gives us 36 inches, right? So each of these 3 feet lengths are actually 36 inches. Okay, so if we were to then sketch this, okay, you've got this, 36 inch by 36 inch package, so it's kind of like a square bottom with only a 10 inch height, right? So it's this kind of a much longer, my drawing's not that great today. Okay, but like a longer package like that, right? Where this value here is going to be your 36 inches, that's going to be 36 inches, and it's this height here, that's your 10 inches. Okay, so again, the length is the longest side on this, and you'll notice that both of these are the same, so it doesn't actually matter which one we choose there, right? So we know that the length value will in fact be 36 inches, and the girth value is going to be going around. So if we've chosen this as our length, our girth will be calculated doing this way, right? Perpendicular to that. So it'd be 10 plus going all the way across here, which is the 36 inches, and then going down the other side, which is again the same height of 10, and then coming across the bottom plus 36. Okay, so you've got two sets of 36, which would be 72, 82, 92 inches here. Okay, and had you defined this as your length, you would have gotten the same value for girth anyway, because you would have come up this way and done 10 plus 36 plus 10 plus 36, so 10, 36, 10, and 36, right, and gotten the exact same numbers. Okay, so either way you would have done it, you would have gotten that girth value of 92 inches. So ultimately here then, our length plus girth calculation is that 36 inches plus our 92 inches, which gives us 128 inches total for our answer. Okay, so there's that example done. All right, so the next one is now we're switching it up to be a different shape. So now we're dealing with a cylinder. Okay, so again, in this example, it's a shipping tube that has a diameter of 1.5 meters and a length of 4.5 meters. And what is the length plus girth measurement to the nearest tenth? Okay, so again, we know that the diameter is 1.5 meters, so that's going all the way across the circle. And we know that the length, or the height of the cylinder, is 4.5 meters. Okay, and we're being asked what is the value to the nearest tenth, and we've talked about that before. Tenth would mean 1 decimal place, so watch your rounding there. Okay, so again, it's a cylindrical shipping tube, right, that we're seeing here. The diameter is all the way across, right, so that value is the 1.5 meters, the length, right, the longest side, okay, so that's the 4.5, but it can't really be anything else, right? There's no other dimension to a cylinder other than the diameter or radius, which are related to each other, and then the length, that's all you kind of have, okay? And so obviously our length value doesn't change. It's the 4.5 meters. What we need to know is what's the girth measurement. How big around is it? So think about what that's talking about. If we're talking about how big around is it, what am I drawing here, right? I'm going around a circle. And if I'm tracing the outside of a circle, we're talking about like the perimeter of a circle, we're talking about circumference here, right? And we did a lesson on circumference before where circumference is equal to pi times the diameter. Okay, so all I need to do to calculate circumference is take my value of pi, multiply it by that value of 1.5 meters, right? And that will give me the girth measurement. Okay, so again, using your pi button here, right, so pi times 1.5, so our circumference or girth measurement is 4.712 meters in this case, okay? So like I said, that's the girth measurement. So now if we're doing our length plus girth, it's the 4.5 meters plus the 4.712 meters. Okay, so we can add those two values together. 4.5 plus 4.712. And we get a value of 9.212 meters. But again, the question did ask us to round to the nearest meter, or nearest tenth of a meter, sorry. So we're just going to look at that first decimal place. So we look at the second one, it's a 1, so we'll just keep that as a 2. Okay, so that value is just going to stay at 9.2 meters. Okay. All right. So the other thing to discuss when it comes with like working with length, so other things besides the length plus girth measurements, is looking at midpoint. All right. So when we talk about midpoint, it's relatively self-explanatory. It's exactly as the name implies. It involves finding the exact middle of an object, right? And again, that's from only a two-dimensional object, looking at just a specific length and finding where is the middle, okay? And again, you could do it with a 3D object, but you'd have to look at each of them as its own separate dimension, right? What's the middle in terms of the length, what's the middle in terms of the width, and what's the middle in terms of the height to find the actual center middle of the 3D. But we're just gonna focus on midpoint of a flat length. Okay, so again, where this might be useful in everyday situations would be things like trying to hang pictures, trying to center an object in the middle of a room or something like that. Even just general folding, where's the middle? You want to be able to calculate that. Okay, so we'll start really, really easy. And if we just have a poster of a pitcher plant that happens to be 13 inches wide and it only needs one nail to support it, you know, where are we going to put the nail and where's the midpoint? Okay, this one I'm not even going to go to the whiteboard for because I think we can kind of just talk about it there, right? So if this length here is just 13 inches and we want to put this up with just a single nail, right, we're going to want to put the nail right in the center, okay? It's what's going to hold it up, it's what's going to keep it straight and not be, you know, off center. So to find the midpoint of that length, all we need to do is cut this value in half, right? So take that 13 inches, divide it by 2, and get 6.5. So what you would do is you could measure out, okay, 6.5 inches is where, right? That's where you're going to put the nail, okay? And then that's it, all right? Okay, this one involves a little bit more thinking, but again, just think it through logically and it all kind of works out, right? So in this case, Steve is hanging a mirror in his bathroom. He wants the mirror centered on a 46-inch wide section of one wall. The mirror came with a hook built into the back of each top corner, okay? And the hooks are 28.5 inches apart. Steve needs to put 2 screws in the wall to support the mirror. How will Steve determine the center point of the wall, and how will he determine the position of the screws? Okay, so again, we start with what we know. Okay, we know that the wall that we're dealing with, okay, is 46 inches. All right, so let's go to the whiteboard again. Okay, so the wall is 46 inches. Let's start with just figuring out where's the center of the wall, right? So like this is one end of the wall, this is the other end of the wall. We want the mirror to be, centered. So the mirror might actually go here, right? So it's nice and in the center. And where's the middle? Right, let's start with the middle of the wall. So to find the middle of the wall, we just need to take the length of the wall and cut it in half. So take our 46 inches, divide it by 2, and that gives us 23 inches. Okay, so we just would start at one end of the wall, measure 23 inches, and go bam. At that point, that's our center, right? So that's 23, or you could start at the other end of the wall and measure the 23 inches, and you're good to go there. Okay. What part B is asking is, how will, I forget his name already in the question, but how is he going to hang the mirror, right? We know that there's 2 hooks on each of the corners, right? So if we go back and just quickly double check our question again. Okay, Steve is our magical mirror hanging man. So we do see here that the mirror came with a hook built into the back of each top corner. So what that means is we know that there is a hook here in the mirror, and we know there's a hook here in the mirror, and they're going to hang off of screws that we put in the wall, right? Because again, the question does ask us, right, how will he determine the position of the screws? So he's got to put the screws in and then hang the mirror. So what we know is that the hooks are also 28.5 inches apart. So this distance here, right? So this distance from this point here to this point here, that's 28.5 inches. All right? So what we want to do is, again, kind of find the midpoint of that, right? If we can find the midpoint of that length, we then know from the center how many inches do we need to go to the left, or how many inches do we need to go to the right. So it's basically saying, okay, what's half of 28.5 inches? Right? Now you could convert this into a decimal and say, okay, well, that's 28.5, and I'm going to divide that by 2, and that's what it is, right? But if we're talking inches, we kind of need to deal with them in fractions of an inch. So if we're going to do half of 28.5 inches, well, let's just do it in pieces, right? What's half of 28? Well, half of 28 inches is 14 inches. And then what's half of an inch? Right? And you might remember when we kind of reviewed fractions a little bit, when I talked about the word of means multiply. So a half of a half, how would you calculate that? Is by essentially doing 1/2 times 1/2. And when we multiply fractions, we multiply the numerators together. 1 times 1 is 1. And we multiply the denominators together. 2 times 2 is 4. So it's 1/4 inch. Okay? So that means that for Steve, who's hanging his mirror, right, he's already measured the midpoint, right, marked the midpoint of the wall there, right, for 23 inches from the side. And now he knows from that midpoint, he needs to go 14.25 inches from the midpoint of the wall, right, on each side. So if he measures the 14.25 from this side, bam, he knows where to put the screw. And then if he goes from the midpoint again, if he's marked the wall, 14.25 inches that way, and there's your other screw. Okay? The other thing you could potentially do with this is use that information about the 14.25 inch, and instead of measuring from the midpoint, you can measure from the end of the wall, right? And if you're going to do that, what you need to remember, though, is that that 14.25 inches is from the center. So you'd have to take that 23-inch mark and subtract the 14.25 inch. Okay? And again, if you do this logically, if you did 23 minus 14, you'd get 9, but then you're also subtracting 1/4, so it would be 8 3/4 inches right, from the left wall, right? So instead of measuring from the center, you could just go, okay, 8 3/4 inches this way, put in your screw, and then you would again say, all right, well, this is the 23-inch mark, and then I'm adding my 14 1/4 inch there. So again, you can just add your whole numbers, 23 and 14 will give you your 37 plus your 1/4, right? And that's 37 1/4 inch, again, from the left wall, right? Because you've gone the 23 plus the other 14 1/4, okay? So that would just be some just kind of basic logic on how we would use midpoint in particular stuff, particular questions, okay? So again, that has the solutions there as well. At this point, you have every bit of information you need to be able to complete the next little assignment, working with length assignment, okay? So again, these questions typically come from the Math at Work 10 textbook, but I pick and choose, right? I don't give them to you in the order that they're listed, right? So because it says question 1 in your assignment, it doesn't mean that it's actually a question 1 in the textbook itself. I go through and I pick and choose which questions I think are relevant, which ones I like, which ones I don't like, and which ones kind of do a good job. So with this one, you can expect to see questions like calculating the length plus girth measurements of objects. You can expect to see questions calculating the midpoint, and you can also just expect general questions of working with length. Okay, so you might have to use things that we've already talked about in terms of perimeters, right? You might have to use things that we've talked about in terms of finding circumferences of values. Okay, so just keep that in mind as you're working through this. Again, any questions that come up, you are more than welcome to email me. If you're not really comfortable with email and you'd rather just kind of actually talk it out, just let me know. Just shoot me the email to say, hey, Ms. Keats, can we schedule a Google Hangout or a Google Meet so that I can ask you my questions kind of as much of in person as possible. Okay, so this one, when you're done, this one should be done by April 15th. Okay, but the other thing that's going to be due on April 15th is your Chapter 2 project, okay, and I will be posting about that shortly as well. Okay, so by, yeah, actually, no, I don't think your Chapter 2 project is due on the 15th. I think you actually have till the 19th to do that. Anyway, I'll go double check that, get that figured out for you, and just keep you up to date. Okay, that's it.